Welcome to another lesson with Kal-El. Today we're going to explore the concept of area. Now, area, the definition in Old Latin just happens to mean vacant ground, right? But in math, we actually know it as the amount of space a 2D object uses. Now, I say 2D object because in a 3D object, we're no longer talking about area, we're actually talking about volume. But this is a 2D object, okay? And so now I'm going to show you how we discover area. Now, in your homework assignment, you'll notice that most of the time you'll start off with a grid paper. And on these grid papers where each line intersect, which means to cross, there's actually going to be a dot. So the first thing you want to do, okay, is that you want to connect the dots with a line. And then from there, because we're talking about the amount of space, we're actually not talking about the outside, which is the perimeter. We're talking about the inside, which is the actual part, what's the space inside the shape. Now, in the very beginning, there's no easy way about this. We just need to count the squares, right? And as I'm counting, I'm going to start numbering them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I know that the area of this shape is going to be 25. And once again, because these are centimeter squares, I know they're going to be centimeters, okay? And then the most interesting thing about this is that it's called centimeters squared. The reason why is because when we're talking about area, we're actually multiplying the length times the width, at least in this quadrilateral, okay? So you can be say centimeters and there'll be an exponent of a little small 2 up on top, that's centimeter squared. Or if you want, you can write 25, SM is the abbreviation for centimeters, and then SQ is the abbreviation for square. Okay. Now, unfortunately, you're not always going to get a polygon, which is all nice and neat on the sides with equal lengths. Sometimes you might see a polygon with unequal sides. So once again, the first step is to create equal squares. I can connect my dots. Now I have my squares. And once again, all I'm going to do is I'm going to start from my top, and I'm going to go from left to right, top to bottom, and just number my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means I know my total area is going to be 16 because that's the amount of space that it took up inside. It took up 16 squares. So 16. These are centimeters. Okay. And it's squared. Or I could write it as 16 SCM for centimeters, SQ, which is the abbreviation for squared. Okay. So when you are dealing with area, you do need to make sure that you have the indicator that it's squared, and by seeing it squared, it'll let us know that it's an area. Now, this is pretty important because if you ever go into, like, say, farming, you go into interior design, building a house, architecture, you always want to know how much space you have available. By determining how much space you have available, that's going to let you know what you can and cannot fit inside that space. So for example, if I am designing a bedroom, and I know that I only have a 10 by 10 square feet space to work with, then if I measure out all my objects, I should be able to fit it within inside a 10 by 10 area. Okay, and now that includes the introduction to area. I know there are better ways to do formulas for areas, but this is just an introduction. Next, I will be showing you how to decompose areas in a different video. Decomposing shapes in a different video and learning how to use the area of a quadrilateral.